tracksuits and red wine, movies for two. We'll take off our phones and we'll turn off our shoes. We'll play Nintendo, though I always lose, 'cause you...
Yep, that's me. You're probably wondering how I ended up in this situation.
This is Alima. She's actually a science student 4th semester, and right now she's going to the class. Oh, wait. She is running late to the class, like always late. And the reason? She takes the longest route to the class on purpose, no shortcuts, no fast lanes, just a long way, every time. Maybe she hopes to see someone? Whatever the reason, she's always cutting it close. Until today.
Oh man!
Miss Alima, do you know what time is it now? I'm sorry, madam. I had some... I'm sorry, madam. Save the excuses. This is not the first time you are late. And every time you are late, you are given the same apology. I'm not here to discipline a dog like a school kids. You are a student now. Time management is not just a soft skills. It's your responsibility. When you are late, you are disrupt the whole class and the learning process. For everyone who arrive on time, it's your final warning. If you are late again, I will mark you as an absent and report this to the faculty. This applies to everyone.
What should I do if I go here? No. I think, yeah. Okay. Here, and here. Yeah.
A vector space is a set of vectors that can be scaled by a constant called scalars and added together. Many physical quantities can be described using scalars alone. However, some quantities require both magnitude and direction. These are called vectors. A vector is a quantity that has both magnitude and direction. In mathematics, other objects like matrices and polynomials can also be considered vectors as long as they follow the rules of vector addition and scalar multiplication. A vector space is any collection of such vectors that satisfies a set of rules known as axioms. Alima usually takes 10 minutes to walk to her class because she follows a longer route. However, she often ends up being late. Wanting to arrive on time, Alima decided to find a shorter path. By using the concept of vector space, she plans to calculate the shortest distance from her starting point to the classroom. Her goal is to reduce her travel time to under 10 minutes by choosing a more direct route. First, to understand how vectors can be used to find the shortest path to class. Second, to explore how vector space helps in calculating the closest distance from one point to another. Third, to apply vector concepts to real-life movement and route problems. Fourth, to learn how direction and magnitude affect the efficiency of a journey. Fifth, to show how using the right mathematical tools can solve everyday problems.
Move to methodology. Step 1, we need to find the magnitude of each path and the direction from gamma B to FSKM. Step 2, coordinate based on the graph gamma B 0, 0, FSG -3, -3, FSKM 0, -9. From this point, we define vector U shortest path from gamma B to FSKM, vector V1 from gamma B to FSG, vector V2 from FSG to FSKM. Therefore, vector V equals to vector V1 plus vector
step 3, we find the magnitude of each vector using the Pythagoras theorem to compare a true path length. Step 4, to analyze deviation, we calculate the angle between vector u and vector v1 using the dot product formula. First, we define the shortest path as a vector u going directly from gamma b to fskm. The coordinates are gamma b 0, 0, fskm 0, negative 9. So vector u equals to 0, negative 9. To find the magnitude of u, we use the Pythagoras theorem, square root of x squared plus y squared. Magnitude of u equals to square root of 0 squared plus negative 9 squared equal to square root of 0 plus 81 equals to square root of 81 and equals to 9. For longest path, we split this root into two segments. Vector v1 from gamma b to fsg negative 3, negative 3. Vector v2 from fsg to fskm 3, negative 6. For magnitude of vector v1, square root of negative 3 squared plus negative 3 squared equals to square root of 9 plus 9 equals to square root of 18 and equals to 4.24 units. For magnitude vector v2, square root of 3 squared plus negative 6 squared, square root of 9 plus 36 equals to square root of 45 and equals to 6.71 units. Now we add them. Total distance of the long path 4.24 plus 6.71, we will get 10.95 units. Then we calculate the angle between the direct path u and the first segment of the longest path vector v1 using the dot product formula. Dot product of vector u and vector v1 is equal to 0 times negative 3 plus negative 9 times negative 3 equals to 0 plus 27 is equal to 27. From before, magnitude of u equals to 9, magnitude of vector v1 equal to 4.24. Now apply the formula cosine theta equals to dot product divided by magnitude of u times magnitude of vector v1. U equals to 27 divided by 9 times 4.24 equals to 27 divided by 38.16 and equal to 0.7071. Then use the inverse cosine theta equals to 45 degrees. This shows the angle between the two paths is an acute 45-degree angle which reflects a slight directional change through FSG.
Based on the calculation, we can compare two different paths from gamma b to fskm. The shortest path has a total magnitude of 9 units, while the longest path, using the route that passes through FSG, has a magnitude of 10.95 units. Since a smaller magnitude indicates a shorter distance, we can conclude that the more direct path from gamma b to fskm is the most efficient. This highlights the importance of route selection in minimizing distance. Through vector calculations, Alimah identified a more direct path to class. This path reduced her walking distance and time, allowing her to arrive earlier than before. The application of vector space concepts provided a mathematical solution to a real-life problem of punctuality. The study shows how vector space concept can effectively solve daily challenges, like determining the shortest route to a destination. By understanding direction and magnitude, Alimah improved her punctuality and minimized unnecessary effort. Therefore, the vector space model proves valuable beyond theoretical mathematics, extending into practical problem solving.
The next day.
Wow, Alimah, you early today?
Thank you, madam. I use a shortcut.
Shortcut?
Yes. I use vector concept. I compared the magnitude of different routes and found the fastest one.
That's smart. You apply what we learned.
Okay, take a seat. Thank you, madam.